Hi, Math. I'm Andy. Yesterday, I was trying to figure out how much money I actually have. And so I took all of my dollar bills and I put them into stacks. And I made 99,999 stacks of dollar bills. And each stack had 99,999 dollar bills in it. And so I was like, oh, if I multiply the number of stacks by the number of bills in each stack, I should get my total amount of money. Now I was shocked to see that my calculator told me I only had $9.99. And that was very confusing because I know I had more than that. So I look at this calculator and I see that it says e to the ninth. Now let's explore exactly what my calculator is trying to tell me about how much money I have. And this is going to have us talk about scientific notation. So the calculator is talking to me in a very scientific fashion. It is giving me the number 9.9998 e to the ninth. Now another way that I could write this in scientific notation, another way that you'll see it is 9.9998 times 10 to the ninth power. Now what this is a way to do, it's a way to take really, really big numbers or really, really small numbers and write them in a more convenient way. So when I take 10 to the ninth power, that's a 1 with 9 zeros after it. And when you multiply that by a number with a decimal in it, you essentially get to move the decimal that many places in the direction of the exponent. A positive direction represents moving the decimal to the right. And as we'll see later, a negative exponent will represent moving the decimal to the left. And we're going to move it this number of times. So to write that number out, the amount of money I would have is 99998, and I'm going to take it 1, 2, 3, 4, 5, 6, 7, 8, 9. And so my decimal place moved 9 to the right. Now you'll notice I have some gaps here. Well, we're going to fill those gaps in with zeros as placeholders. And so when I take the decimal away originally and I look, this is the amount of money. Now seeing this is kind of tough, so maybe we'll throw some of those commas to separate the places. And so if I throw commas in here, this represents $9,999,800,000. Now another thing to be cautious of is this might not actually be the exact amount of dollars I have, because my calculator screen was limited to only take it to 4 decimal places. I end up with zeros here, so I might actually have a couple of thousand more dollars than what this is telling me. But because this number is so big, we kind of just don't worry about this. Now, another way to think about scientific notation, as I mentioned, is really, really small numbers. Like, for instance, we are full of cells. And it turns out if you were to take an inch on a ruler and measure the size of the cell, you wouldn't even be able to see it, because a cell is 2.3 times 10 to the negative 6 inches wide. So, you have like this cell with all of its parts in it, and it only measures 2.3 times 10 to the negative 6 wide. Now, as I said, a negative exponent moves the decimal to the left. And so I'm going to take the number 2.3, and this time the decimal is going to go to the left 6 times. 1, 2, 3, 4, 5, 6. And we'll put our decimal there. Now you'll notice there's some gaps, so we're going to fill those in with zeros. 0, 0, 0, 0, 0. And so this would be the size of a cell in inches. So again, this becomes a little mundane, it becomes a little too much, and when you start working with really, really small numbers or really, really big numbers often, these zeros can kind of get confusing. So we write numbers in scientific notation using the e or using the times 10 to the power. And that's how we can write really big or really small numbers. Now let me kind of just give you the quick rule about scientific notation. You'll notice something that's really, really important. The number that you're writing in scientific notation will always be a number that is less than 10. So notice we wrote it as 9 point something and 2 point something. It'll always be a one-digit number to the left of your decimal. But your number will also always be greater than or equal to 1. You'll never see scientific notation written as 0.1 times 10 to the or anything like that. Because if I'm going to write a number such as 0.1 times 10 to the third, let's say, what I'd rather do is move this decimal one place to the right and call it 1 times 10 to the second. Now notice I took away from the power because I already moved the number to the right. So if I move 0.1 to the right 3 times, and I move 1.0 to the right 2 times, I'll end up with the same value. So again, your scientific notation will always be a number that is less than 10, but bigger than or equal to 1, and then you'll have the decimal and every other number behind it. We use scientific notation, again, to represent really, really big numbers and really, really small numbers.